Okay, so let's go ahead and jump in on the webinar, Using GPS GNSS, Part 1. I want to talk just real quickly about what we're doing in Traverse PC with this next release, version 2023 R1, and our focus on GPS and GNSS workflows. And I'm going to go ahead and open up the help topic that you're going to find in our unified help system. So you can scroll down to the bottom of any of our web pages and click on Unified Help System, and Traverse PC will open this up for you. This is both available locally when you run Traverse PC and also on the web. So the one that you click now will bring you up to the July 2023 release 1 that's coming out. And one of the things you're going to notice in this release is that there's a section for itself called Using GPS GNSS. And this is really where I want to hang out just for a minute because we're putting a lot of focus on this, and I think you're going to be able to find some tools that are very, very helpful for you. So let's drop down and take a look at this. Solution, TPC, and an MLID RTK with Ntrip. So we've been watching and talking with a number of the sort of new generation manufacturers. Bad Elf has got a little unit, MLID has a unit. You can go right down the line. And really what we're talking about is, not too many years back, we had to go with a major equipment manufacturer, and we could easily spend $40,000 or $50,000 to get a base and a rover GNSS unit. They sometimes have sort of lower standard ones, like sub companies, and maybe you're going to spend $20,000 or $25,000. But that means getting the receivers, the data collectors, the software, the whole 9 yards. But a lot has changed. I want to talk about that just real quickly because it opens the doors for us to do this quite a bit differently. The solution I'm looking at here is one involving an MLID Reach RS2+. MLID is a company out of Hungary. I think some of the equipment is manufactured in China, like so much of it is. But these guys are brilliant. And they've provided enough tools on their end that we can combine with the tools on Traverse PC's end. And really, we've got a complete solution for a lot of GNS workflows. And let's just take a look here at what has changed. We now have GNSS. So L1 band, the 1575.42 megahertz, with course acquisition. Of course, we still don't get the P codes for the military, but at least we've got the civilian access or public access to course acquisition. We've got L2 at the 1227 megahertz and a lot of satellites. So I can go out anytime now, anytime 24/7, and have a full constellation of satellites. I can do a lot of work under the brush and still get a fix. It's pretty neat. And then we're kind of keeping our eye on the L5. That's the new band that's out for aviation and first responders, and maybe that'll become available too, I don't know. We've got better cell phone coverage in the field. So the solution we're going to work on today involves an Ntrip correction over a cell phone hotspot. We've got better Ntrip networks and free casters. So with an existing Ntrip network, of course, I can use their core stations, but I can also create my own core station and cast that the same way that the Ntrip networks do. Kind of interesting development here. We've got better GPS GNSS equipment and prices. We've got better and sometimes free mobile and desktop apps. And we've got better and sometimes free use of the web cloud for data. So let's just drop down and take a look at this solution that I've got a picture of here. And I put this out on the hood of my rig because I want you to see that I can take this in the field and have everything I need. Or we're going to talk about some kind of nifty field office options that some of you may be able to take advantage of. So if you're already a Traverse PC user, you can pick this solution up for $2,600. and I want to talk about how that works. So I've got TPC 2023 R1 running on a laptop, and the asterisk says I already have that. I've already got a cell phone and a hotspot, so this is my Android Samsung S10. I've got a range pole and bipod. I've got these sitting around that I've used with Total Stations forever. I'm already subscribed to the ORGN, that's the Oregon Department of Transportation GNSS network that provides the NTRIP. And what I added to create this solution then was an MLID Reach RS2 Plus, that was 2600. I'm using MLID Flow, that's the mobile Android app on my Android cell phone. That runs on any Android or iOS tablet or phone. So that's the software that's running this. And then I'm going to use the MLID Flow 360, which is their web browser app that helps me manage those projects. So what we were interested in doing here at Traverse PC in the first 2 quarters of 2023 is say, what if we just started with one of these solutions? In this case, a single MLID Reach receiver, and our cell phone or tablet Traverse PC. Let's see what we could actually do with this. Let's see how far we can get. This promises centimeter accuracy. So put a golf ball on the size on the top of any survey point. That's really the accuracy that I've got. I've got great network coverage. I can, if I need to, pick up a second MLID and do a base rover for the areas where I don't have cell coverage, and I don't have the radio antenna hooked up to the receiver right now, but it comes with the antenna for that $2,600 price. So now the 2 receivers can share corrections over that antenna. It's the long range, low raw antenna. They are phenomenal as far as distances they cover. So let's just drop down and take a look at this solution in a little more detail. And we're going to come back and visit this in part 3. Because in part 3 I want to make sure you kind of understand what all the pieces are. But here's a closer look. So 2023 R1 with a laptop, it introduces or includes simplified workflows for importing and exporting the CSV files, along with tools to better calibrate existing surveys with GNSS. So running TPC on a laptop allows you to calibrate existing surveys to GNSS positions in the field, after which you can do additional corridor searches and stakeouts. So that's huge. How many surveys do I have over 30 years of surveying that are at 5,000, 5,000? Or maybe I've got a survey on a projection that isn't supported by the GNSS equipment. So I've got to calibrate that back and forth. Well, I can do that calibration in the field. So I can go out and tie down at least 3 points with whatever GNSS I'm using, and then I can calibrate the rest of my survey to that, or I can calibrate that to the rest of my survey. Either way, I now can send points back out to the field to do additional work. And some of you, this is kind of interesting, or you could have someone in the office do the calibration and export the points back to the cloud for use in the field. So this is something else I want to kind of cover in these next 3 parts, is that we really don't connect everything up with wires anymore. And while I'm collecting data in the field with this system we're looking at, whoever's back in the office has access to those same points. And whatever points that person back in the office puts into the project, I have access to in the field. It's kind of a different way of thinking about things. I'm using my cell phone for a hotspot. So this RTK NTRIP solution requires a Wi-Fi connection to the ORG and NTRIP network via hotspot. Okay, the hotspot's provided by the cell phone, but it can be provided by any capable device. This particular MLID receiver has a SIM card slot. So I can put a SIM card in here and it can provide the hotspot. The range pole and bipod, This is one I've had that I've used for backsite setups. The only modification was to add a magnetic mount for the cell phone, which can be used on the range pole. I like that best because it's the same one I use in all my vehicles. I just pick my phone up and put it on the mount that holds it there with a magnet, and I just lift it off when I'm done. Well, I found that's handier in the field than having a clip that I have to unclip, whatever. I'm showing here the, remember I said the AMOLED Flow runs on any Android or iOS, so this is my iPod or iPad, and I've got a clip that I use to hold that. I don't like this as well because it's bigger, heavier. I have to unclip it when I want to head through some brush and don't want to worry about damaging the iPad. But I wanted to just have you see that really any device you want to use works with this. And remember, we said that's a free mobile app. So I'm not paying for a controller or controller software. Remember, I said I want to see how far we can get and what we can do with this before we say this is going to be a viable solution. So far, I'm pretty impressed. And a lot of it's just because of stuff like this. The ORGN TPC GNSS network. So AMOLED Flow mobile app on the cell phone just has you log into your account and get the RTK corrections. So AMOLED Flow can get RTK corrections from an TPC network, another AMOLED Reach RS232, set up as a base station on a known point. I can also set up my own caster that sends those TPC corrections to the cloud that I can pull down just like I would from the ODOT TPC network. So that's another option for me as well. Here's the interesting part about this. The AMOLED Reach RS2 Plus for 2600. We may repeat this whole process with one of the Bad Elf devices, and we're looking at a couple others as well. Part of it is being able to handle the workflows. We're going to talk about this here in just a moment. But pretty much all of them now are multi-band GNSS receivers. The price is competitive. This one comes with this long-range antenna, so I can communicate with the base station if I want. But I can get RTK when it's available via the one rover and an TPC network, the one rover and a caster network. I can pair that rover with another reach for a base station, or when RTK is not available, I can still use it as a data logger for post-process solutions. So kind of a neat thing is that this particular receiver logs data as well. So I can use this as a rover for single point solutions, but turn on the data logging. And then I can come back to the ORGN GNSS network and pull down the Rhinix for that same time period. And I can post-process this in what's called AMOLED Studio. So I'm not even paying for post-processing software. I certainly could go out to Opus and post-process there, but AMOLED provides that solution as well. Then I'm running AMOLED Flow. That's the free mobile Android app. Runs on Android or iOS. And this app provides basic data collection and stakeout. It does the data sync in the cloud and RTK corrections and shows point locations on top of a street map like the one used in Google Maps. And I'll show you that in just a minute. It also provides all the user controls for any AMOLED receiver you're using. That AMOLED receiver actually can set up its own local Wi-Fi network. So if I don't have a hotspot or Wi-Fi available, I just turn this thing on and now the tablet and the receiver are communicating over that local Wi-Fi network. So all the corrections, any access, any settings are all done on the mobile app, communicating directly with the receiver. And then AMOLED Flow 360 is the free web app, and it's used to manage the projects to sync data with the AMOLED Flow mobile app. So one of the things we think about right away, and I remember being down in Montserrat a number of years ago after half the island got destroyed by a volcano. And I was out there running a total station, and I had 4 rodmen. In that particular country, you've got lots of laborers. Okay. Well, now what we can do in something like this is they could each have a rover, and all of those rovers can be communicating with the project, and anytime they collect a point, that point automatically goes up to the cloud real time. And that would all happen in this Emlid Flow 360 web app. And then, of course, any points that need to be staked out are just sent up to the app in the cloud, and they're now available to all 5 rodmen with their GNSS rover. I mean, it's kind of a different world, a different thing, and I kind of like where we're able to go with it. Now, I know I'm spending a fair amount of time here. We're going to come back and devote a whole webinar to that, but I just wanted you to see kind of why we are pushing with this solution. A lot of it's the price, of course, but we also are pushing for streamlining these workflows, so I'm not trying to hook up a cable and figure out how to get stuff there. Or I don't have to come back to the office, do a bunch of work, go back out to the field just so I can do additional corner search or stakeout. We're simplifying all of that using the capability of Traverse PC and the capability of the GNSS manufacturers. Okay, so we've taken a look at a lot of that. Let's just drop into some GNSS workflows real quick and kind of see how that works. Remember, all of this is available to you right now if you just go out to our website and scroll down to the bottom and click Unified Help. So what we've done here is to kind of start getting a framework for this. We've said, okay, let's take 3 options for coordinate reference systems. I'm going to have my survey on the same coordinate reference system as my GNSS equipment. And that's where we're headed with this Part 1 example today. Move my survey to the same coordinate reference system used by the GNSS, in this case the NTRIP network, or I can continue to use my survey's coordinate reference system with the GNSS on whatever reference system it's using, and Traverse PC will take care of that calibration stuff for me. I've got different survey types. Sometimes I'm just going out and collecting data. Sometimes I'm doing stakeout. Sometimes I'm out there in the field looking for additional points I can tie so I can develop a better calibration. And then we've just listed 3 sort of simple GNSS types. RTK via an NTRIP, RTK via base and rover and radios, and then anything that involves post-processing where I'm not doing real time. So if I just break it down into these 3 coordinate systems, 3 survey types, 3 GNSS types, I've got now 36 possible combinations. And we're going to be able to tackle a bunch of those with Traverse PC. But I just wanted to give you an idea real quickly of kind of the breadth of this. The neat thing about GNSS is that I can tackle lots of scenarios. And Traverse PC is going to, we're in the process now of simplifying as many of those workflows as we can. Even with the stuff I'm going to show you today that's coming out in the 2023 R1, you can do all of this now in your Traverse PC, even version 22. But we're simplifying the processes. So let's take a real quick look at, of course, a simple workflow would be if the data collection, if we're just picking up data, and the survey uses the same coordinate reference system as our GNSS. So I just go out and pick up everything in state plane or low distortion projection that I'm using for my area, and not a problem. So in the office, I'm using that projection. In the field, I'm using that projection, and I can coordinate back and forth. Now, this is the one we're going to work on today, a more complex workflow. And in this particular one, we want to use GNSS to stake out a foundation on an existing survey that's not on the same grid or coordinate reference system as our GNSS. And I'm just going to flip over here to Emlid Flow, and this is the project that we're working on. And we're going to see that this is a project we started back in 2017. The coordinates were 5,000, 5,000, and I just need to go stake this thing out using whatever GNSS equipment I have right now. Let's click on that again and see if that'll bring that up. There we go. So here's the site, and we're going to drop in and take a look at that in more detail later. But this is what we're talking about coming up with a workflow. So I'll jump in on this one and we'll pick that up later. But I want you to see that there's a lot of pieces to it. Okay, then let's take one final look at two things working using GNSS with surveys. And then we're going to drop into calibration real quick. So when we're talking about bringing GPSS or GNSS into our surveys, we're either using the coordinate reference system of the GPS GNSS equipment, so we just match your survey's coordinate reference system to the one used by the GNSS equipment. And in Traverse PC, we just select that same CRS and we're good to go. So with this option, sharing GNSS data with your survey involves just importing and exporting data without any calibrations. We can use an existing survey's coordinate reference system. So you may have started at 5,000, 5,000. You might be in a state plane. You might be in a UTM. And you basically want to keep that survey where it is, plus use your GNSS equipment. So we're going to calibrate the GNSS to our survey. And Traverse PC does that with something called a site calibration. So you do the calibration, you set it up as a site calibration. Now you continue working in your local survey at 5,000, 5,000, but anytime you go back out to Google Earth or GNSS, it reverse calibrates. And that local coordinate gets reverse calibrated to a geodetic position that matches, in this case, your GNSS equipment. So it's just a pretty cool way to continue to work the way you're working, but be able to communicate with the GNSS. And then the one we're going to look at today is you can also convert an existing survey to the coordinate reference system used by your GNSS. Again, it involves calibration, but this is a little bit different in that 2023 R1 has expanded the capabilities to raw data and drawings. And basically, we're going to calibrate up to your GNSS coordinate reference system, and then the survey is going to adopt that. And it's going to act as if it wasn't even calibrated. So it's going to act like I had started the survey there in the first place. And again, remember I said we're trying to simplify these. So we want to really sort of take a lot of the busy work out of it and make it as simple a workflow as possible. And this is the one I'm going to show you today. So all of these, the last two I talked about here, involve calibrations. And you're going to see how this works today. We're looking at what's the easiest way for me to create the calibration in the field. And what I'm going to show you today is I went out and I said I'm going to pick up 0.201 on the GNSS receiver, and in the description I'm just going to say equals 1. I'm going to do that same for 202, 203. You need at least 3 points to get a good calibration. You can pick up more if you want. I think I got 5 or 6 on this one. And then we're going to come back and we're going to create a calibration from the traverse that we imported from those points. And after the calibration is applied, we can come back and use something like the stakeout report to see how good a fit we got. Then I can calibrate in the field. So I don't have to come back to the office to get locked in with my GNSS receiver. I can do that in the field, taking my laptop out there, or because these points get sent up to the cloud as I collect them, these points I'm using to calibrate, someone back in the office can export from the Office app, do the calibration, and then they can send the calibrated stakeout points back into the cloud, and now they're available to me in the field. I mean, it's kind of like magic almost. So now I can work with that calibrated survey data to search for existing monuments I haven't located yet, to do stakeout, or to collect additional site, topo, and boundary data. So we're going to look at both of these ways of calibrating in parts 1 and 2, and I think you'll have a pretty good handle then on kind of how I could take my workflows that I typically do and find out if I could use this sort of simplified solution with Traverse PC and one of these GNSS manufacturers. So that's where we're going with this. And I know that that took a little bit to explain, but I didn't want to call us too short on that. So now let's drop over to the EMLID Flow 360. This is their Office app or desktop app that runs in any browser. And let's talk again about Part 1, Part 2, and Part 3. So in Part 1 today, we're going to do a stakeout on a job that we started in 2017. So we had gone out and done this with a total station. We sent everything off to the architect to get started on the design for the house. We went through the building permit process with the city and produced the preliminary site work that they needed there. And now the builder is ready to get started, and the client called and said, will you do the stakeout? So I contacted the builder, and I'm going to walk you through kind of that process that I went through with him to get him ready to start putting forms in the ground here. Next, in the next webinar, we're going to drop in on a PUD that we put together back in 2007. It's mostly built out now, and the owner of Lot 9 wants to locate a house on that property. But this lot, this lot, this lot, this lot, and this lot to some extent are going to have their views of the lake down here affected by what happens on this lot. So we're going to come in here and do some sight lines and some profiles and say, what happens if they build a story house here, a story and a half here, or a two-story house here, and where can they place this on the lot so that they have the least impact for the views on these other lots. And there's an architectural review board here. So we're going to submit that information to them so they can actually make some decisions about, in this case, where this house can be placed on the lot. Okay, so this is what the layout looks like. Here's the garage. Here's the rooms with the views. The front of the house is actually right here because their access is off of this paved easement. This is actually a panhandle lot. And then in part 3, I want to come back and talk to you about all the pieces involved in a solution like this. Here's the EMLID Flow 360, but we'll come back and actually visit all of these pieces and how they coordinate. And I want you, out of these 3 sessions, to be able to say, yeah, these are my workflows, and yeah, I could use a solution like this, whether it's 2 receivers so I can have a base and rover and radio corrections, or 1 receiver using an N-trip network, and accomplish a lot of what I do at centimeter accuracy. Okay, so let's stop there and take any questions.